All right. So now we're looking at how do we now complete the square. And so we're going to do these questions, completing the square. So this question says express the quadratic 2x squared minus 8x plus 5 in the form a times x plus h all squared plus k, where a, h, and k are real numbers. They are all real numbers. So let's do this now. So we need to just complete the square, put it in that form. Now, generally, the form that I use to remember this is I always try to write a function. When I'm completing the square, we're going to write it in the form f of x is equal to a into x plus h. Instead of saying x plus h, I say x minus xt squared, x minus xt, where xt is the x value at the turning point. So you can write it as f of x is a times x minus xt squared plus yt. All right, so you can write a function in this form, and it's the same as that up there. All right. So now to complete the square, now we need the x value at the turning point. And the x value at the turning point is given by this formula, minus b over 2a. X value at the turning point is minus b over 2a. Now b is the coefficient of the x term, and a is the coefficient of the x squared term. And so minus b over 2a is going to be minus 8, and minus 8 is positive 8. And then we divide it by 2 times a. 2 times a is 2 times 2, and 2 times 2 is 4. And so xt works out to be equal to 2. So that's xt. xt is 2. Now after we find xt, we need to find yt. Now yt, now remember that what happens? Coordinates occurs in pairs, a x value and a y value. So when we find xt, we can then find yt by finding f of xt. So we just need to find f of xt. F of xt will give us yt. F of xt in this case is going to be equal to 2 times, so it's going to be 2 times 2 squared. So we're just putting this 2 into the function. So it's going to be 2 times 2 squared minus 8 times 2 plus 5. All right, so we put 2 in this function right there, and I'm getting minus 3 from my calculations. So I get minus 3. After receiving minus 3 now, it's now okay. All right, so now I can complete the square finally. So finally, I can write that f of x, we can write it in that form. F of x is a, remember a is the coefficient of your x term. So f of x is now a, where the coefficient of your x squared term is 2. So it's 2 times, in bracket, x minus xt, so it is now x minus xt, here xt is 2, so it is f of x is 2, in bracket x minus 2 square plus yt. Plus yt is minus 3. And so this is the completed square form. So that's your answer. That's the solution. F of x is 2 times x minus 2 all squared minus 3. So this is how we complete the square. Very easy question. All right. Now, this question says, hence for f of x, which is 2x squared minus 8x plus 5, determine the minimum value of f of x. The minimum value of a quadratic function is the y value at the turning point. And so the minimum value of f of x is yt. And in this case, yt is -3. Yt is -3. So that's the minimum value of f of x. Then they ask you for the value of x for which the minimum occur. The value of x for the minimum occur is when x is equal to xt. Is when x is equal to xt. And we found that this is pretty much when x is therefore equal to, what did we find for xt? All right. So we had found a value for xt, and the value that we found for xt is, we found xt to be 2. And so xt is 2. And so what we're then saying is that the value at x for which the function is minimum is x is equal to 2. Now this question asks us find the range of f of x for the given domain. Now the question did not specify the domain, and so when the question doesn't specify the domain, you always assume x is an element of real. So this take into account all the possible values of x. All right, so just assume that when they don't give you the domain, x is an element of real. So we're assuming that the domain given us is x is an element of real. So now the range of f of x, or the range of the function, is going to be that f of x is always going to be greater than, this is the range, f of x is always greater than or equal to the minimum value, right? Because this is the lowest point on the curve. So f of x is always greater than or equal to -3. That's the range of f of x. Now right here, it asks for find the values of x for which the curve cuts the x-axis. Now to find the value of x for which the curve cuts the x-axis, we're solving this quadratic equation. All right, so we're solving the quadratic equation when it's equal to 0, because on the x-axis, y is equal to 0. So all we're gonna have to do is set the quadratic equation equal to 0. So we had completed the square, right? So I'm gonna solve it using the completed square method. Now, of course, you could have used this form right here and set it equal to 0. But given that we already complete the square, why not utilize this formula, right? We already complete the square, so might as well just utilize this form. If we're gonna factorize this one, it doesn't matter which one we use, but since I already completed the square, I just want to do it in a completed square way. So 2 times x minus 2 all square, because that's now f of x, 2 times x minus 2 all square minus 3 is equal to 0. All right, so we're solving for roots, remember. So if we were to bring over the 3 and divide by 2, what we're solving then is x minus 2. So we're solving x minus 2 is equal to, let me say x minus 2 all square. All right, so I'm doing 2 steps in one. X minus 2 all square, I bring over the 3 to get positive 3, and then I divide by 2. All right, so that gives me x minus 2 all square is equal to 3 over 2. Now, how am I going to find the root? That's pretty simple. Now, I need to solve for x. So the first thing I need to do is square root this. And so I'm getting x minus 2. X minus 2 is equal to, when I take the square root of one side, I have to take the square root of the other side. And so it becomes the square root of 3 over 2. But remember, when you take square root, you get plus or minus. All right, and so the possible solutions then is that if I add 2 to both sides, I'm getting that x is equal to 2 minus the square root of 3 over 2. I'm going to write the square root of 1.5. So x is 2 minus the square root of 1.5. Or alternately, we can say that the root is x is equal to 2 plus the root of 1.5. So 2 plus the root of 1.5. That will also give us the root. All right. So these are the two roots. All right. So what this works out to be is 2 minus the root of 1.5. 2 minus the root of 1.5. I'm getting 0.775 from my calculator. So that's 0.775. 0.775. All right. Now for right here, now we have 2 plus the square root of 1.5. So if we're adding 2 plus the square root of 1.5, we're getting that x is equal to, you put that in a calculator, 2 plus the square root of 1.5, I'm getting 3.22. 3.22. And those are the two roots. All right, the two roots, 3.22 and 0.775. All right, now next thing you want to do, you always want to check that the root is correct. So to check that the root is correct, put in your x values back into the function and see if you get that it's equal to 0. So check, for example, when we got 3.2247, say 2 times the answer square minus 8 times the answer plus 5, I get 0. And so yes, the root is indeed correct. So these are indeed correct. So those are the two roots. Very easy question. All right, easy, soft. All right. Now the next function, the next part of the question says, sketch clearly the graph of f of x and clearly label stationary points and the x and y intercept. Now this might look unfamiliar. Now when it says stationary point, what it's talking about is the turning point. All right. State the turning point on the graph. That's all they're saying. And then they say sketch the x and y axis intercepts. Easy. So first and foremost, I just like to start with my axis. I start with my x-axis and my y-axis. So y, x. Now look at this now. Because the graph has a positive coefficient for a, right? This is 2. And so what I know is that it turns, it's going to be a minimum point, right? It's a minimum point. So the graph smiles. That's what I know. And it cuts the y-axis at 5. I also know that the roots are 0.77 from around here and 3.22, right? And I also know that the function turns at 2, -3. So 2, -3 is the turning point. So I like to start with my turning point, right? 2, -3. I like to sketch the graph first, and then I put in the other information. All right. I like to just sketch the graph first. Whoa, pretty poor right here. Let's try that again. All right, so my graph not drawn to scale, but right here is the turning point, and the turning point is 2, -3. So 2, -3 is right here. The next thing is we're going to tell them the root. The roots again are, this point is 3.224 or 3.22. So that's 3.22. And then this root right here, I believe that was 0.775. So we can put our 0.775. Right? So that's that root, 0.775. Now our y-axis intercept, this right here is 5. All right, this is 5. And then just to label the function now, this is the graph of y equal f of x. All right, this is a graph of y equal f of x. And that's pretty much how we sketch this right here. All right, so they didn't give us a specific domain. All right, and so This is how we would sketch the graph of this function. Very easy. It's not an accurate sketch. Could have been done better. I could have utilized, the arrows and the curves and everything to pretty it up. But guess what? It's a sketch. All right. So that's no issue. All right. Now,